do, put it all in one data set, obviously. You got more points, which has what on your, I'm trying to figure out, now granted you're a bias sample, you're a hugely biased sample, you all came here at 8:15, you're all Matthew 44 students, you're all trained to think about bias, right, even if you're tired and undercaffeinated. So you're hardly a random sample. But supposing you were a random sample and I wanted to do something like this to test how well we can approximate 10 seconds, why would more data, more good data be better than less good data? You decrease your margin, which means you got a more precise estimate of what 10 seconds looks like, right? It's back to Chris's idea again. I mean, if we can get more data, it's going to keep shrinking that margin. Remember that formula? Well, you don't have to remember if you don't want to, but just realize it's at work. That root n, as n gets bigger, the entire thing gets smaller. So we're going to decrease that margin. Even if we multiply by 2 at the end, it's going to keep getting smaller and smaller and smaller. But then I thought, though, let's not combine the data because you guys might be learning as you go. Right? You might be saying, oh God, I said it's 6 seconds. Maybe I should, slow it down. Now it's 8. Slow it down. Now it's 10. I could have dealt with this by doing a double blind or a single blind study, but whatever. We'll do that next time. So what I want to do is, I first want to look at all 3 data sets together. Not 244-ish, but 243-ish. So I'm going to use this to make 3 box plots of your data. Okay? Now, if you've forgotten how to do this, let's relearn. Because I like this idea. I like this idea. It brings up, I'm so glad you said this a little bit, because it's super fun to be able to, there's more you have to be concerned about when you're measuring averages than when you're measuring proportions. And we're going to get more into that as we go through the rest of the day and into next week. But let's go to our plot menu, second y equals. I'm going to turn on 3 box plots, 1 for each data set. So the first one, plot 1, I'm going to turn it on. And you know what? Make it modified. Let's see if there's any outlier data. There were some big and small numbers in there. Let's see if they were so big and small related to the other data that they would be considered too far out even for the spread of the data. So modified box plot, L1, change your frequency to 1. We don't want grouped data in this case. And mark it, that's fine to mark it with a box like that. Remember the annoying little thing you have to do with the 1? Anybody getting a Y when they try to type a 1 in the... Oh, good. You figured that out. Good for you. All right. Do the same thing with plot 2 and plot 3, but just turn them on for list 2 and list 3, and then we'll graph the whole thing at once. All right. Plot 2, L2, and plot 3. And I'm glad we guessed 3, Elizabeth, because I can't do more than 3 graphs here. I'm really glad you said 3.
You said 3.
Did I say 3? I'm going to give you credit for it. I shouldn't take credit for this stuff. It's your idea. So now I got 3 plots turned on. We'll take a look at it. If learning indeed did occur, what should the box plots do with respect to each other?
They should come together in the middle.
Yeah, you'd think, right? And also, how would the middle change, do you think, if learning occurred? On average, over all of you. Any ideas? It's okay if you don't have any ideas right now.
The middle one should be higher.
Okay, a cool smaller variation maybe as we refine into that 10. Good, I like that idea. Let's take a look. I'm gonna check my y equals. I'm gonna hit zoom 9, invalid dim. Oh, I set something up wrong. Hang on. Yep, number 2 set up wrong. That should be a 1. There we go. Why is it not registering? Because I'm not pressing enter. Hang on. 1. There we go. Zoom 9. Okay! That's kind of what I thought it was going to look like. That's kind of what I thought it was going to look like. You guys now, see what's happening with the box plots? They're getting more refined. Very nice, which means you guys are you're hovering in closer onto that 10. Where is 10? I'm guessing it's right about there. Let me check the scaling on this. No, it's not actually. The scale is 5. Oh, maybe it is actually. Because the min is, the min is 5. So yeah, that is 10 right there. This is 10, right? Oh, I put it over here. Yeah, that's 10 right there, that little dot. Running up right through there. This is kind of weird on the delay. So, yeah, here's 10. We got some outliers to talk about. Fun. Crazy spread. Yeah, if you didn't put the data in, you're not gonna, that's okay. That's why I recorded it all. You can put it in later if you want to play with it. Yeah.
Right? Like, yeah.
Cool, fair. So now the question is, let's make the intervals around each of the 3 data sets. This is not inferential. This is strictly descriptive, yes? This is just what happened with you guys. This is your data. This happened, this happened, this happened. And you guys described what happened pretty well. On average, It did this, but did you also catch this? That's what I thought was going to happen. That's the learning. On average, you might have been too low originally, and then you shifted and you shifted again. Very Bayesian of you. Very nice, very Bayesian. Yes, brother. Sorry, that's a very subtle joke. I was in the hallway Tuesday evening. Monty Shaney, I don't know if you know Monte Shaney, as I call him, great dude. His wife Carrie, and Donna Raymond, and me, all in the same hallway, nobody else. Well, her little chihuahua was there too, but there was just the four of us in the hallway. Tater, yes. And Monty walked out, he's like, well, what do you think? 4 statisticians in the hallway, what are the chances? And I said, well, since we're all here, 100%, I'm feeling Bayesian today. And Bayesian's a kind of statistics that says, start with an original prediction, collect some data, and start shifting your prediction. That's what you guys are doing. Like, it's what we're doing right now. It's pretty badass, all bad jokes aside. But that's what you're doing right now, which is totally badass. So let's learn the TI trick to get the interval. On average, first trial, did you guys target 10 seconds? On average, first trial, did you, on average, if we build an interval around this. So when I say you guys, we look at this box plot. Let's assume, on average, first trial, how well will COCC students target 10 seconds? Assuming you're a representative sample of COCC students, which you're not, but let's assume you are for the sake of argument because you're here. Cool? So here's the shortcut on the TIs to do it. Can we start the camera again?